Okay, welcome to Unit 2, Activity 2, more contextualize exponential functions as models for percent change. So in this unit or this video, we're going to keep on practicing exponential functions and how to write them as a percent or whether they're increasing and decreasing. Before we get going here, and you can go ahead and read the learning outcomes on your own, but really, we got to be able to get you to be able to communicate what you're doing and do it in multiple ways. So that's what the multiple representations means. We're gonna do some problem solvings and then apply these skills and some real life stuff so that we can keep growing with our abilities and our problems we're tackling here. So let's go ahead and warm up a little bit and take a look at the warm up skills. And let's look at number one. If you were to calculate this function here, I'll see if I can get my pen working, and I'm going to ask you to decrease 200 by 10%. So in other words, and I'm looking at number one right there. In other words, if you wanted to go down by 200 or down by 10%, what you'd really need to do is take 200 and you want to go down 10% of 200. Now, 10% of 200, a lot of people will write this step right here. That's what I'm going to do. I'm going to jump right to there. So 0.10 is the same thing as 10%. The line above it is describing as 10 over 100, but 10% of 200 is 20. So really, if I wanted to decrease 200 by 10%, you're just taking away 20 for a final answer of 180. Same thing for number two. If I wanted to decrease 80 by 72%, you have to take the original amount, 80, and take away 72%, which is 0.72, of the original amount. Now, if I'm doing that, and I got a calculator here in front of me, 0.72 times 80 is 57.6. Now, if I'm going ahead and keep that up, what does that equal? 80 subtract that number is just 22.4. Okay, so notice you can come over here, and that's my final answer. I notice I only did it in a couple steps because I'm always just going to take that percentage and subtract off 0.72 because that's how you write the decimal form of the percentage. Now, in the other example, decreasing by 200, excuse me, decreasing 200 by 10% is the same as 90% of 200. Get it? Decreasing 80 by 72% is the same as what? What would you write? Again, notice that two percentages have to add to 100. So if I'm going to decrease 200 by 10% and say it's the same as, and I'm not trying to confuse you, so I won't do this step in the next couple, but it's the same as 90% of the original amount. If you decreased 80 by 72%, well, what's left over? Probably, what is it, 28? So if I took 28% of 80, you should get the same answer. Okay, in other words, 0.28 of 80. And if you go ahead and do that on a calculator, you should go ahead and get the same answer, 22.4. So you can think of it in different ways, whatever works for you. Let's go ahead and do a couple more here. Let's increase 480 by 35%. And I'm not going to do this stuff in the next couple of examples because it's just too much. So if I'm going to increase 480 by, notice increase means add. So I'm going to increase it by 35%. And now notice 35% of 480, well, what is that? So 480. Now 0.35 times 480 is going to give you 168. When I add that to 480, that's 648. Okay, so that's the actual answer. But if I was going to increase it by 35%, another way to do it, right, is just to add the 35%. So watch what happens here. And I don't know if you'll be able to follow this now or in other videos. Instead of doing it this way, check this out. If I took 480, it's in both of those terms, and I pulled it out front, then you'd have 1 plus 0.35 equals some number, right? Or 480, so if you can follow, 1.35, that's going to equal 648. So it's two ways to write the same thing. But what I'm trying to get you to recognize is that this equation here is A times B equals some number, right? So notice there's my initial value, my growth factor, and what we've been messing with is the formula AB to the X. So really, if I want to increase something, and I probably should have done this for the decreasing one, 1 plus 0.35, we've talked about that before. 1 plus a B, excuse me, I get that wrong. I've been calling that whole thing B. B is equal 1 plus my rate. So if you want to in the future, you can cheat. Even if I'm asking you to increase 24 by 6.5%, watch what happens. You could take the initial amount, 24, let's write it down here, and 6.5%, well, if I added that 1 plus my rate, 0.065 written as a decimal, 1.065. Now that will give me, I'm doing it on my calculator here as we speak, 25.56. Now this is directly related to this B equals 1 plus R, which I've been trying to talk to you so long for. If we did it the old way, 24 increased by 0.065, the original amount. You could say 24 plus, and again, I don't know what that is, 24 times 0.065 is 1.56. And if I add these two together, you're going to get 25.56. And notice they're the same answers. So a lot of times when we're doing this warm up here, or talking about a percent increase or decrease, you can add it if you want to increase it. And if I really wanted to, to do it this other way, I could decrease it 200, or here's my B. If I wanted to decrease it by 10%, 1 minus 0.10 would be 200 times 0.90. Okay, and that's what they were trying to illustrate in here in the first place. So I don't know if that helped at all, but messing around with percentages and understanding which ways they work. But let's go see if we can apply them to discussion here. Pause the video. Go ahead and read the problem about full-time equivalent students, and we'll go on from there. Okay, if you're back, notice that you're starting out with 4,000 full-time equivalent students. And that's actually a true statement back for these numbers. These were actually real statistics back then. And the college is always trying to encourage us to grow. And they want us to grow by 5%. Now, when they do, remember, as soon as they say percent, it's always y is going to equal a b to the x. You're in an exponential formula, okay? Anytime you have something that's changing at a constant multiple or constant percent change, you know that that's the formula. And not only do you know that, just as a little bit of review, A is the initial value, and B is either your growth factor or your decay factor, your percent change. Now, notice I'm going to do two things at the same time here. Making the table, if I want to grow by 5% each time, you just have to take the 4,000 and multiply by 1.05. If I do that, you're going to get 4,200. So that's your first number here. Once you do that, do it again. 1.05 times that new number is going to be, I think it's going to be 44,110. And I've kind of got ahead of myself here, or gone ahead and got these numbers for you. But I really want to point out, notice I'm growing by 5%, but this year, the increase was 200 from year 0 to 1. The first year, I grew by 200, and this year, I grew by 210. If you take away 4,200 plus 210 would give me my next number. and I'm going to be growing exponentially because each time 5% of a bigger number is a bigger number. So for instance, if I wanted to find out the next one, 4410 times 1.05. Sorry if you can't read that. Oh, and that's going to get me 4630.5, I believe. Let me double check that. Sorry for the delay. Yep. So it's 4346. And notice if I were to subtract that from 4410, this increase, and if I change my color this time, it went up by 220.5. So each time I'm going up a little bit more because I'm taking 5% of this number, but the next time I'm taking 5% of a bigger number and 5% of a bigger number. And this is how interest works on your credit cards and why people get into debt and can't get out from it, because it just continuously compounds, which we've been talking about in earlier examples. So that should be a common term now. And if I go ahead and do it one more time, 4630.5 times 1.05. Oh, I think it's like 4862.025. Sorry, I'm a little sloppy. Okay. Let's see. What else can we talk about? So if you wanted an equation for that, remember you have, back to my blue pen here, an initial value and the growth factor. Now we just talked about something that's growing in those warm-up examples. Remember, B is equal to 1 plus an R. And if my rate is 5%, 1 plus 0.05 is just going to be 1.05. So that's my growth factor. My formula is actually going to be my initial value, 4,000, times 1.05 to the x. Initial value, growth factor, because it's above 1, remember, it's increasing because b is greater than 1. And a lot of this might be reviewed too. And so there's my formula. Now the last part, well, not the last part, but part C here is talking about the fact that, well, you have an annual increase of 5%. 10 years later, some people might think it's 50% higher. Because if you took 4,000 times 50% and you did that on a calculator, oh, what is that? 50% of 4,000? So, oh, 50% higher. So, sorry, I just checked that for a second. So that's 2,000. So in other words, you're going to go up by 2,000 from your original amount. For a total of 6,000. Now that's this case. If you're adding up and say, oh, you would think it'd be 50% higher. But if you're doing 5% per year for 10 years, remember every successive year, hopefully you're following what I'm saying, every successive year, the amount that's increasing is more and more. So it's not just a straight 50%. And if you wanted to figure it out, all you have to do is 4,000, 1.05 to the 10th. And what's going to happen is you're going to have, excuse me for a second while I do my calculations. You can do it on a calculator too, or pause the video. 1.62889 and a bunch of change. If I times that number by 4,000, notice the real amount when you're doing it exponentially with exponential growth is more than the 6,000 that you would think if you went just 50% higher. So that's the problem with that. You're not going up by 50% after 10 years. You're going up 5% for 10 years. It's a big difference. Okay. Exponential growth will also be the reason that rich people stay rich forever, or that you can retire early if you put your money into an account, because the more money you have, it keeps growing and growing, and its interest makes interest on itself, if that makes sense. So hopefully that helps. We'll stop there. I'll come back and do another video for number 2.